Okay, so in the last video, we looked at a type of linear relationship, a certain one with two unknowns, a y and an x, and we examined how these variables change as we go along our x and y plane. And we drew what this particular relationship would look like. Now, I just want to look at in this video what the effect is of changing the number in front of the x. So in this previous one, we had that y equals 2x as our relationship. Now I'm just going to shift this number up by 1 to give me y equals 3x. Now I'm going to draw another table of values here, and I'll work through this a bit quicker. If you're a little bit lost, you can check the previous video where I talked about this a little bit more at length, but I'm going to, for time purposes, do less values, and also just because I have a pretty small graph here, so I'm going to just do it for space purposes as well, like this. Now, what do we have here? Well, we have that y is always going to be 3 lots of x. So y will always be triple the value that x is in this particular instance. So when x equals -1, my y will equal -3. That's 3 lots of -1. 3 times 0 gives me 0. And when x equals 1, my y is going to equal 3. Now, plotting this on our graph, well, I have that when x equals -1, y equals -3. So that's going to be my first point here. Ooh, app's glitching a little bit, guys. Sorry about that. Here we go. My next point's going to be at the origin again. And when x equals 1, y is going to equal 3. Now, we expected this graph to be a straight line. We expected this to be linear because once again, although the values have changed, they are still going up in a uniform manner. As x goes up by 1, y goes up by 3. We have a uniform linear relationship. So drawing this, drawing a line through these points, I get, as we anticipated, another linear relationship. Now, let's actually compare this to the one we had before. Well, cool. They're both straight lines. That's a similarity we can pick off. They both have variables which are constantly of x and y, which are constantly changing. And this one, though, to me, I don't know about you guys, but it looks a little bit steeper. So the slope of this, as opposed to being like something like this or that, which it was before, it's become quite a bit steeper, hasn't it? Just compare these, 1 and 2. Our graph has gotten steeper. So by observing this, well, that means that, well, as my number in front of my x has increased, my graph has gotten slightly steeper. Now, what if I took maybe, I don't know, y equals 4x? Well, we would assume that, okay, let me just draw it on here again. When x is, say, and I'll actually, what I'm going to do, I'm going to color coordinate these graphs. But let's take, say, y equals 4x. I'm going to do this in purple. When x equals -1, y will be -4 because it's going to be 4 lots of x. The y value, my vertical value, will be 4 lots of my horizontal value. When x equals 0, y equals 0. And when x equals 1, 4 lots of 1 will give me 4. So connecting these, I get something even steeper for y equals 4x. So we can establish a relationship here. As my number in front of x goes up, my graph will get steeper. And this is a pretty significant idea in linear relationships. Now, this thing in front of the x is what we call our gradient, or in other words, the slope. So this determines, this 3, for example, here, determines how steep my graph will eventually end up looking like. And we can see that as my gradient, as my number in front of x goes up, as my gradient goes up, my graph will become steeper. And this kind of makes sense intuitively because my second graph in this diagram, for y to go up 4 times x, the graph's steepness had to compensate for that because my y is increasing more in the same amount that x is increasing. So say with my first graph, for x going up by 1, y went up by 3. But in the second case, for the same 1 unit change in x, I went up by 4 instead. So we would assume that this would produce a steeper graph. And the larger this number gets, the steeper my graph will become. Now, we've just looked at positive whole numbers here, right? What if we looked at a positive fraction? So let's look at another linear relationship. Well, I am going to give you this one. So y equals x on 2, or half x, however you'd like to write it. And keep in mind, I've introduced a keyword of the gradient. And now, don't get too overwhelmed, because I know this is a new word and we haven't really looked into it too much, but for the moment, we're just looking at how this number affects how x and y change. We are going to talk a lot deeper about the gradient in the coming videos, but we're just going to look at some common types of linear relationships. So here we have y equals x over 2. Now, in other words, this is saying that y will always be half of what x is. So keeping that in mind, well, I'm going to import the x and y plane again, and we will examine this idea with our fraction here. Now, drawing up a table of values, we have x, we have y, and I'm going to put in the same values I had initially, so -2 all the way through to +2. All right, now this is where it's going to get a little trickier. Now, y here is always going to be whatever x is divided by 2, or in other words, just half of x. So taking all of these x values and figuring out what the resulting y should be, we're just going to half whatever the value of x is. So when x is -2, y is going to be -1. That's going to be half of 2. When x is -1, well, half of -1 is just going to be -1/2, or -0.5. Half of 0 is just 0. Half of 1 is +1/2. And half of 2 is just 1. So drawing this in, we have, all right, when x equals -2, y equals -1 here. When x equals -1, y equals -1/2. So that's going to be approximately here. When x is 0, y equals 0. That one's pretty easy. When x equals 1, y equals 1/2. And when x equals 2, y equals 1. Now, once again, we get a linear thing. I'm going to sound like a broken record a little bit, but these are really important points to drive home, is that x independently just changes. It's going to go up by 1, and my y is going to here instead go up by half for every step of x. Now, let's draw a line through here. And this is the graph of y equals half x, or x on 2. And let's compare this one to our other ones. Well, you should immediately be able to see that the slope here is a lot more gentle. This is a very gentle slope in comparison to how steep these two are. So we can say that, well, anytime we have a fraction here, well, y is actually going to change at a slower rate than x is. Because in all of our other cases, well, the intervals between y values were more than the intervals in the x values. But here, the intervals in the y move at half the speed of my x intervals. So we would expect that, well, okay, when x goes up by 1, y should go up by half of that. Let me actually do that in a regular pencil so you can see that. As x goes up by 1, y goes up by half. As x goes up by another 1, my y is going to go up by half. So a fraction will result in a more gentle slope here. And it's important to note, I've written intervals of x, x going up by 1 unit, but this pattern sort of applies all the way through. It applies for a variety of different intervals. Say I took maybe x going up 2 units. Well, for x going up 2 units, I would expect y to go up half of that because of the linear relationship that I've been given. So I would expect y to go up to just 1 unit, which actually it does. Now, what about back here? I can also say that I can pick out any increment that x increases by, and y will always be half of that. Say I had x going up in an increment of 4 units, from -4 to 0. Well, my y should go up 2. Here, I might actually write this, 4 units. My y goes up half of that, which is 2. And lo and behold, when I look up to my other dot that I've drawn, that is exactly what happens. My y has gone up 2 units, so from -2 all the way up to 0, in the time it's taken from x to go from -4 to 0. So these are just some basic adjustments we can make to this number in front of x. Now, here, it's important to note that, well, I could have also written this as just half in front of x. So this number is still the kind of number in front of the x that we talked about. So we've looked at 2 particular linear relationships here, and we've observed 2 trends. We've observed that as we increase the number in front of x, the slope is going to get more, we're going to get a steeper slope. And as this number gets smaller, and particularly when it goes into the fractions, so when y goes up at a slower pace than x does, we get a more gentle slope. Now, those are the 2 big takeaways we're going to get at in this video. And in the next one, we're going to talk about the effect of this number being negative. Because you may not have noticed, but all the numbers we've been dealing with in each of these examples have been positive. We've had +4, +3, +2 in this case. So we're going to, in the next video, look at the effect of taking a negative gradient, a negative number in front of this x. I'll see you there.